Hello everyone, my name is Dr. Peter Konlabi, Cooperative Extension Specialist in Agriculture Application Engineering with the University of California Agriculture and Natural Resources, and also with affiliated faculty member with the Department of Biological and Agricultural Engineering at UC Davis. In this video, I'm going to talk about Airblast sprayer calibration. This is intended to serve as an overview of what the steps and procedures are. And also for those who want to apply this would serve as some type of tutorial for you. Let's start off by looking at some considerations for efficient and effective spray application. There are three components that we consider. There are first we have the operator or the crew involved in the application. We have the sprayer, which is the equipment, and then we have the spray, which is the material. Now, for the operator, we need a well-trained and knowledgeable operator, someone who knows what he or she is doing, and is familiar with what we consider as best practices, and is willing and able to also put these into practice. And then someone who is attentive and a quick responder, is able to respond quickly to changing situations in the field. When it comes to the equipment, as a sprayer, we need it to be well maintained. It should be in good condition. All the components running as they are supposed to be running, so that at least it starts it becomes a starting point for the application. And then we also need it to be well calibrated, which is what we're going to talk about in this video. And it also needs to be well adjusted to the target canopy. Meaning the target canopy characteristics can differ from situation to situation, from field to field, and so forth. So the calibration has to be done for the sprayer, and in that the spray nozzles and all those have to be adjusted, well adjusted to the canopy, so that you are sure that the spray will be applied to the canopy and not just into open air and thereby waste material. And then when everything is done, it also needs to be operated well, and this also brings in the operator or the crew. Now, when it comes to the material, the spray material, a starting point is that the spray has to be applied, the chemicals be applied in consideration of the pest involved. It should be timed well, considering the pest, and not just that, but it also has to be timed considering weather conditions. So the weather condition has to be conducive for the application. The material has to be applied accurately. That is where the calibration comes in, and it has to be well directed to the target canopy. So this adjustment from the equipment side and the material also has to be directed to the canopy, so that you are sure that we have the material in place. Now, in consideration of the objective of the application, we need the spray to be adequately penetrate the canopy. We don't want it to not penetrate or over penetrate, so that the material does not stay in the canopy. We want it to get into the target canopy and be able to have the opportunity to settle, deposit on the foliage and so forth. And then at the end of the day, the spray mix needs also to be optimized for on target canopy and deposition. We'll look at some of these. So in this presentation, we are going to cover basically the sprayer and the spray. And so what is calibration? What is sprayer calibration? Basically, it is the adjustments made to a sprayer based on measurements taken to ensure that the correct amount of material that is, you could look at it as a spray mix or the active ingredient is applied. So we take measurements, and then we do adjustments based on the measurements, and we have an objective in mind, which is the rate of material to be applied, the amount of material to be applied to our target. So that is what we have in mind, and then based on that, we do measurements of various components to see if this rate is what we are achieving from the sprayer, and then we do adjustments so that we can achieve what we are targeting, or what our objective is. So why do we calibrate? Quickly, let's look. We'll talk about correct or accurate calibration versus incorrect calibration or not calibrating at all. Now, it's a best practice. Calibration is a best practice. The objective is to verify, at the end of the day, to verify the amount of material that is being applied to the target. It is a best practice to know that and be confident about what you are applying, and not just to guess and assume that the sprayer is doing what you intend it to do. It will help to achieve accurate application rate, and not doing it at all, that is not calibrating, or incorrect calibration can lead to inaccurate application rate. So if you're applying and you are not achieving what you are supposed to apply, you may be applying less than you need, or maybe over applying and thereby wasting material and so forth. That is costly to the operation, and it's also not sustainable for the environment. So it's a starting point for effective pest control, while minimizing waste and negative human health and environmental impact. If it's not done well, or it's not done at all, we could end up with some possible ineffective application. And again, accurate application or correct application, calibration, sorry, will ensure compliance with the law as represented by the pesticide label. We know that the product label is the law, and so it helps to stay within the confines of the law, what the application rate is you're calibrating to achieve that, and not go beyond that. And then so if it's not done well or done incorrectly, and possibly it's an over application situation, then you could end up with possible illegal residues on the treated crop. And so these are some of the positives to doing it right, and the negatives to not doing it at all, or not doing it correctly. Now, why do we calibrate? Quickly looking at these images, these are from a vineyard, or from vineyard scenario. You can see the first photo here is showing very early in a season where there is no foliage on the vines and so forth. This represents a different scenario where you have some foliage. The setting is different compared to the next one here, and even looking at the next one. These are different situations. So the basic idea is that we cannot use the same settings on the sprayer to apply to these different scenarios. So when do we calibrate? But ideally, at the beginning of the growing season, it is a good time to do a calibration, because it affords the opportunity to also do some maintenance and make sure that the sprayer is functioning as it's supposed to function. Parts that need to be replaced have been replaced, parts that need to be cleaned, and like let's say looking at nozzles, if you have clogged nozzles, you can change those nozzles or clean them. If you have nozzles that are worn out, those can be changed and so forth. So the beginning of the season, of the growing season, affords that opportunity to do so, and that time would be the time where you can set the sprayer towards a small amount of foliage in that sense. And then later on, whenever there is a significant change in conditions, it could be change to the canopy, could be changed to the ground condition, moving from one plot to another plot where the vineyard or the orchard design is different. Those will call for calibrating for those specific situations. And when you are changing, when there is a change and you're doing it, you are recalibrating some aspects of it, or may not necessarily need to be adjusted. So only those portions that need to be adjusted would need to be adjusted. Like, let's say if you move from a ground where it's a bare ground, and you do your calibration on a bare ground, and now you are going to apply in a similar setting, but there is vegetation on the ground. This will present different conditions, and their impact on the traction on your spray or tractor is going to be different. So it's important to maybe measure travel speed again, forward travel speed again, to ensure that you have the right number, and use that in determining the application rate, so that will help to get the right settings for the different situation. Here are the some fundamental concepts underlying calibration. At the base of it, we are working towards the application rate, which basically is the volume of liquid applied over or divided by the area covered. Usually this is measured in gallons per acre or liters per hectare. Application rate, as I mentioned up here, is volume applied over area covered. If we break it down, we can look at the sprayer output, which is basically the combined flow rate from all the open nozzles. So that would be in maybe gallons per minute. That's output per time divided by swath width in maybe feet by travel speed in miles per hour times time. So with all of these, there is consideration for the conversion factors that come into it. But basically, it's sprayer output times time divided by swath width times travel speed times time. And if you cross out the time, you end up with sprayer output divided by area rate, which is what this will give you. The product of swath width and travel speed will give. Then we look at all of this, and a basic formula that comes out of it is GPA, which is gallons per acre, which is the application rate, is sprayer output divided by land rate. Okay, so here one aspect that I want to look at is the swath width. So the swath width is basically the area, the width that is covered, and then that multiplied by the travel speed will give the rate at which the area is being covered. Okay, and that's from here, the rate at which the volume is being applied divided by the rate at which the area is being covered will give you the application rate. Now, this applies to various situations. This applies to the same concept applies to all types of sprayers, whether it is airplanes or boom spray, ground boom sprayers, or Airblast sprayers, which is what we are talking about in this presentation, or even backpack sprayers. The idea of the sprayer output, or the volume divided by area, sprayer output divided by land rate, is the same. The way to measure it may differ, and yes, they do differ, but at the end of the day, what we are looking for is the volume above the ground, the area covered beneath, or the rate at which the volume is being applied over the rate at which the ground is being covered. In Airblast spray spray application, the swath width is the row spacing. Okay, this is in a vineyard situation, this is an orchard situation, it is the same thing. Swath width is the row spacing. Going back to the basics, we can see during the application, we have the canopies. Okay, the canopy immediately adjacent to the sprayer are considered the target canopies. So at any point in time, this is a target canopy. We can probably say it's a moving target, but this is a target canopy. So this is a target row. This is a target row. The spray is being applied to this, not to the next one or the next. Obviously, if any droplets miss the target canopy, it might end up here on the ground or in the air and potentially be carried away. If we consider the target canopy, it's bounded. Each target vine or tree is bound by an equivalent of the row spacing times the tree spacing or vine spacing within row. Okay, if we shift this around, then we'll see this better in another scenario. But the row spacing by the tree spacing is the area that bounds one vine or one tree, or generally we say one plant stand. Okay, and it is the idea is that each side is being applied, each side of the spray is being applied to that area. So as the sprayer advances forward, this width, which is the row spacing, is basically what we are looking at covering. But the spray is intended to apply to half of this, and then on another pass in the next row, another half is covered. So it is sufficient. It is just sufficient and also most efficient to have the sprayer set in a way that the droplets or the spray will sufficiently go through or penetrate through the canopy with very minimal spray coming out to potentially drift by the wind to unintended location. So in view of that, we will talk about the how to consider the need to consider the air assistant, the amount of air that is being used to move the spray droplets. In Airblast spray application, the air is acting as the vehicle to move the spray droplet into the target canopy or up to the target canopy and into the target canopy. But that same air can continue to move spray droplets when they are available and still available in the air. Another consideration is that looking at the profile of the target canopy, would have to use that. We have to consider that into determining how many nozzles are going to be spraying. so that we are not applying too much above or too much beneath the target canopy, where in that case we'll be missing out, just wasting the spray, just wasting material, and also potentially resulting in drift. So if we consider the different types of, or the different scenarios of the target the target canopy, we'll see that it would be important to think about the amount of air we are using to move the spray to the target, because they represent different levels of resistance to the flow. And then also it's important to consider the configuration of the nozzles, so that we are not just spraying into the air and wasting the material. So if you look at the nature of air coming from an Airblast sprayer, because of the fan, for a single fan sprayer, the behavior of the spray on the left side and the right side are not exactly the same, because of the rotation of the fan and how the dynamics in the air. But generally the air, when it exits from the airspeed, when the air exits from the sprayer outlet, the airspeed drastically reduces after that exit, and then continues to reduce gradually with distance away from the sprayer. And so the difference in airspeed through the target canopy can be significant between different airflow rates, and also depending on the target canopy characteristics, which means that the airflow rate needs to be managed to minimize spray loss beyond the target canopy. And we can look at how far. Here there is an Airblast sprayer, and you can see this is I mean, I don't have the distance here, but it's about, I think, about 60 feet or something. But the idea is that this is the size of the Airblast sprayer. You can see how high and how far the spray can reach. This is using all nozzles at full blast from the sprayer. So definitely, because Airblast sprayers are made to be versatile and be able to apply spray to small trees, to medium trees, and to large trees, it means that we have to adjust the air and also the volume of liquid that is being applied, thinking about the size and the characteristics of the canopy, the target canopy. So depending on how you set your sprayer overall, and looking at, in consideration of the airflow rate or air speed, the air assistance that you are using can either help to achieve the best outcome, that is the coverage as well as deposition on the target canopy, or it can be a foe, meaning that it can work against you. It may end up pushing the spray through the canopy and out of the canopy, so that you have less amount of spray depositing within the target canopy, whereas if you had adjusted the air, it could have gained more deposition. Okay, so back to what we talked about, the target canopy. In Airblast spray application here, the immediate tree canopy or vine canopy, the immediate one adjacent to the sprayer are considered the target canopy. At any point in time, the target canopy is or are or the target rows are the ones just immediately adjacent to the sprayer. Okay. And let's look at this animation. So when we apply, basically the concept is that each half of the sprayer, each half of the sprayer, or each side of the sprayer is applying to half of the roll, just half of the roll. So if two sides of the sprayer are spraying, then we are doing half on the left side and half on the right side, and putting all that together, we have a full canopy covered. That's half plus half. These are half of each side. So this means that the sprayer has to go around one side, in one pass on one side, and come back in another pass, or in one pass on the other side, or the opposite side, to attain full coverage on the canopy. It is important because if you are doing only one side and skipping, then we are not giving the opportunity for there to be sufficient deposition on the canopy, and that can work against the objective of pest control. So if we are considering the two-sided spraying from both sides of the sprayer, this is the formula we use. It's GPA, representing the application rate, gallons per acre, equals to GPM, that's from the two sides, which is the total flow rate from all open nozzles from two sides, times 495, which is a composite, or all the conversion factors put together. It's the 495 in this case, divided by mph, which is the travel speed, the forward travel speed in miles per hour, times the row spacing. So if you put these values in, we should get the gallons per acre. So this is the basic formula we use. Now, in this other view, we are looking at maybe spraying from one side, and this may be for maybe the outermost or the edge of the field. When you're playing, spraying from the edge of the spraying the edge of the field from outside of the kind of the outside of the orchard, but this can just simply apply to calibrating and looking at one side with the assumption that the other side is a mirror version of that one side. This is also possible to use, and in that case, that one-sided spraying for calibration means that we have to divide the row spacing into two, and when you divide that into two, these two move up, and so we end up with the 990. Okay, the 990 conversion factor here, simply because the 2 is coming up to multiply this. Okay, so it basically is the same formula. It's just, are you considering one side or the other? So if you look at these two formulas, you see that here the gallons per minute, the flow rate or the spray output is coming from both sides, whereas in this case it's coming from just one side. So that has to be put into consideration, whether you're using this formula for two sides or you're using this formula for the one side. So now let's quickly look at the steps, and then we'll look at some demonstration of the steps involved. So the steps could be as follow. We first determine the travel speed. To to know for sure the setting or the sprayer, the tractor speed setting that we are using. Depending on the tractor you're using, you select the setting that you're going to use to do your application, and then we measure or we determine what that is. It's not going to depend on the speedometer. Is going to be different from ground condition to ground condition. So it is important to determine that. So we first determine that, then we will assess the air profile, look at the air profile with the target canopy in mind, and then use that to determine the number of nozzles that we should be using for the application. And then we'll go ahead and select the nozzles. If you have already are going to use whatever nozzles you have on, it's just a matter of just shutting the nozzles that we are not going to use. Otherwise, it also means that going to the catalog to find the particular nozzles that are needed to be used in that situation. And then once we have the nozzles in place, we'll go ahead and measure the sprayer output from the nozzle, the total flow rate from nozzles. And in some cases, you can use look at the flow rate from all the individual nozzles and put them together. Or there are also other ways to just look at the bulk material applied and then divided by the number of nozzles that are in place. So using that, we will get the application rate. If the application rate we calculate from what we have measured is what we need, or as close as possible to what we need, close meaning that it's less or equal to, that is sufficient, that is okay. But if it's more than, we really need to adjust. So we adjust the sprayer output by applying some formulas to know what we need to change. It would be either travel speed or operating pressure. We'll look at that in a minute. And then once we do the adjustment to arrive at the application rate we are targeting, and so this will sort of end the whole process. But I always recommend that beyond that, we need to also assess the spray coverage, that is finding out where the spray is reaching within the canopy, and then that becomes an assurance. So that becomes an assurance for the person doing this to know that I've calibrated my sprayer, it is giving what I intended to give, and also the spray, the target canopy is also receiving it, or the spray is reaching the various places within the canopy, and I'm satisfied with that. Okay, so let's look at the first step, determining ground speed. Basically, this involves identifying or measuring out, marking out a known distance, 100 feet, 200 feet, whatever. But it has to be such that we can have a sprayer, travel that whole distance depending on the space you have. But 100 feet is sort of a minimum that one can use. And so you will drive, if you have two people in, and plus maybe an operator, one person will watch the starting flag, another person will be looking at the ending flag, and the first one will give a signal as to when the sprayer has reached this point. So the sprayer starts from this end coming, and we use a fixed point on the sprayer. So this can be the front end of the sprayer, so a fixed point that is moving. Once that point reaches the first flag, this hand comes down to indicate that they should start timing using a stopwatch, so that once the sprayer or the front end of the tractor reaches the next flag, this person stops the timing, or stops measuring time, so we can determine the time it takes for the sprayer to travel from here to there, and then we will use that time to calculate the speed. Another case is this, when we have maybe just the operator and the person doing the measurement. Then you can put a flag right still right in front of the sprayer, so the sprayer the tractor will push the flag. So this person will observe when the front end of the tractor touches the flag, and that becomes the start point, and then stands here to observe when that same point touches the next flag, and then that is the time stops, and we can use that to do the calculation. So this is when you have less than this is the first case is looking at maybe when you have 3 people. The next case is looking at when you have the operator and then 1 person doing it. And then this is a situation where you can use, maybe if you have just the operator is doing it, this is one thing that one method that can be used. In this case, in this other method, we are doing manual counts of number of trees passed. So the sprayer is going to still travel in between rows and then count the number of trees passed. The trick here is that, and I've shown it here, the first tree is basically a count of 0. Where you're starting it, that is a count of 0. So after that, then you have 1, 2, 3, 4, 5, and whatever number you are looking at. But in this case, 1 represents this unit distance, okay, just a tree spacing or vine spacing, and then 2, the next spacing, the next spacing, the next spacing, so that this becomes 5 spaces put together. If you start counting 1, 2, 3, 4, 5, 6, in that case you would end up with 6 of the row spacing, and then in that case the speed calculated will be less than what it's supposed to be, and so then you adjust everything based on that, and then it's incorrect. So it's a count of 0 to start with, and then 1, and that makes it the first space, next space, and so forth. All right. And then if there is also the opportunity, maybe in a vineyard, or in the area, the vineyard or the orchard affords the ability to use an automatic GPS tracking device, then that will also work, because that one uses a ground movement and not the rotation of the tires. So unlike the speedometer, this will be using the actual movement on the ground, and so the GPS will be more accurate than the speedometer, which is not based on GPS movement but based on the rotation of the tires. So this is some field demonstration. Sorry about the shakiness of the video, but it still demonstrates what we are looking at. So these 2 people are marking out the distance inside a vineyard. So and I would say that using this measuring tape is better than using the roller. The roller comes in handy, we can use that, but in my practical field experience, the roller has a tendency to give value that is off, especially when you have a ground surface that is rough. So using the measuring tape like this can give you the stretch and give you the actual distance, and it's more accurate in that sense. So, right. And so once we have the flags marked out, it's also advisable to have multiple flags that represent the whole cross line in the cross line in the tractor's path, and this is going to help the person observing from the side to be able to see and to stand in a good position to see all three flags aligned, and then use that as a basis of determining the start or the end point of the time measurement. So here is an example of the actual measurement taking place. So this person started off, gave an indication of when the sprayer reached the first flag. So there is a person that is doing the measurement, the time measurement, and is observing at the end to see when the sprayer reaches the front of the tractor, reaches the next flag, so that becomes the end time for the speed measurement. And then once you have obtained that, we bring that into this formula, where S1 here is representing speed. This is 0.68 is putting all the all the conversion factors together. So we have feet that will convert to miles, and then we have seconds that will convert to hour. So putting those together, it comes to 0.68. So 0.68 times d, the distance measured, maybe 100 feet in feet, divided by the time measured, which is in seconds, and this will give you the value in miles per hour. The next step is the next. Okay, before we look at the next step, I'm just showing you here, in a very early in the season, just before the foliage start developing, if there is a need to apply, or even when there is very small, maybe there is bad break and there is foliage and so forth, and you can see that in this case the target canopy is very small. There is no foliage all over the place, so we don't need all the nozzles to be on to apply spray to just small target. So if you look at this, which is just a demonstration, not an actual application, you can see that there is a lot of wastage. So it represents waste, and this is not what we want to achieve. We want to have the number of nozzles that will actually put the spray onto the target, and not spraying a mist into the air or spraying a mist into the space beneath that, and potentially causing a lot of drift. Okay, so this is a consideration. If we look at this particular case here, we can see that there is in this particular demonstration, we see the wind blowing in the left direction, and it's blowing the left direction. So you can, if you look at the spray, you can see the nature of the spray is sort of moving towards the left. The right side spray is not really going the same way, behaving the same way as the left one. And if you look at the next flag here, we see that the sprays, the wind is really a bit low, and we can tell that in this particular scenario, this is beyond the scope, but I wanted to point it out. In this particular scenario, we see that there are wind breaks in place, and so even though we have high wind showing here, we see that it's reduced on this side. So it's just an idea to show how we can try to minimize drift, maybe using windbreaks. But looking at the overall scenario here, we see that we don't need all nozzles to be on to apply spray to the target in this scenario. Okay, so we need to really be able to find where the spray will be going, where the spray is heading from each nozzle. Okay, and to do that, we have to determine assess the air profile, and so we can attach flagging tapes like these to each nozzle. Maybe we don't need all the nozzles to be tied, but for the demonstration purpose, we tie all the nozzles. We look at the spray, just the air blowing, and look at where the spray from each nozzle will potentially be going, because the nozzle sprays and the air as shown by the profile here is going to carry the spray in that direction. So we can use this to determine where spray will be heading from each of these nozzles. And so look at this and say, well, which nozzle should I turn on, or should I leave on? Which nozzle should I turn on? Because the nozzles that are just going to blow spray into the air or into empty spaces that are not going to be effective for the deposition or coverage, these actually need to be turned off. These need to be turned off because they will add to drift, or they increase the potential for drift, and then they also reduce the amount of material that is available to be applied to the entire orchard or vineyard. So after we have assessed the air profile, we know which nozzles to shut down or to close, and which nozzles to leave open. So we will determine the number of nozzles per side that need to be on, that we'll be using to do the application. And then based on that, we also know, based on that, we will determine the desired flow rate that will achieve the application rate. Now, we start off with an application rate in mind. Let's say 100 gallons per acre. We have determined our miles per hour, our travel speed, by step one. In step one, we have already measured, or we already know the row spacing in the orchard. The formula we started with, when we turn it around, we do change of subject to the spray output, which is gallons per minute from two sides. This is what we have: gallons per acre times miles per hour times row space divided by the 495. When we put these values in, the known application rate, the measured travel speed, and the measured row spacing, then we will get a value. Okay, we'll get the flow, the total flow needed from all sides. Then we would have to determine now how much flow do we need from one nozzle. Okay, in this formula we find the flow from all nozzles on both sides. The next formula here, we are looking for the flow from one nozzle, and in this case here we put the value that we have determined from the top here into that. Remember, this is flow from all nozzles, and then this is the number of nozzles that we determine from the air profile assessment. Put that in, and we get the amount of flow needed from one nozzle. This is when we are looking at flow from both sides. If we use a one-sided spraying, it is similar. It is a similar thing, but just that we use a 990 here to obtain the flow from only one side, and then down here too we will use the number of nozzles from one side, not from two sides. So just bear that in mind. So then from there we go to select nozzle. You know the nozzles we are going to use. This is an extract from the TJET catalog, and assuming these are the nozzles, air induction holocone nozzles that we are trying to use, then we will first look at the operating pressure. What operating pressure are we trying to use, or are we planning to use? So here we are looking at 120 psi. We're going to go down that 120 psi to look for a flow rate that is close to the flow rate we determine for one nozzle. So assuming that this is a value, okay, so we come down until we find that value, which is as close as possible to it, and then we go towards the left. Okay, we go along the row to find which nozzle it is, and then we select that nozzle. That doesn't mean that this is going to give exact value. This is the catalog value. Okay, but we will talk about after this point what do we do. So let's say in this particular situation we have identified the AITX 825 VK as the nozzle we want to use. We have selected that. This is also an extract from the TJET catalog, which is showing holocone disc and core nozzle. Okay, so it is just similar. Identify what operating pressure you're going to use. Go down to find which flow rate is closest to the flow rate you are going to use. You are planning to closest to the flow rate you have determined from the calculation, and then follow that row to find which nozzle it is. Okay, and sometimes you might find some flow rates. You can find some similarities, like here you have 0.39, you go down and you have like 0.35. So if you're using this one or that one, you have to do different adjustments, but these may be close to what you are calculating. So assume we have selected the nozzles. We know we have put them, we know the number of nozzles we need, the particular nozzle positions. We have selected the nozzle from the catalog, and we have put these nozzles on the sprayer. Now what? We want to measure the sprayer output from these nozzles. Different methods, and we are looking at these different methods. The first method, we need to follow this instruction. You pipe the sprayer on the level ground, because the level of the liquid is important here. You fill the tank with clean water to overflowing, so it's at the top of the of the tank, and then or you can also, if you can see a little bit into the tank, you can mark a particular level as the your top mark. and then run the sprayer in a fixed position with the spraying from either two sides if you're looking at the two sides, or one side if you're looking at that. So this will spray for say 1 minute, and then you fill the tank back up with clean water back to that original mark that you set, and then you will calculate the you will use that to know how much was sprayed out, because how much was sprayed out was how much was filled back, was needed to fill it back to that level. And so using that, you can now calculate the sprayer output as a measured volume divided by the spraying time, and then make the adjustments based on conversion factors. The second method is different. Okay, in the first method, we are looking at the spray output, the sprayer output from the bulk spray output from all nozzles, because we are only looking at how much was sprayed and how much was filled back to get that volume, but we are not looking at individual nozzles. In this second method, we are looking at individual nozzles. Okay, we fill the sprayer tank to half. So note the difference. In the first method, we have to fill the sprayer to full, or to some level that we can see from outside of the tank. Now, in this second, you don't need that, because you are not going to do that bulk thing. You fill the sprayer to about half, which is the recommended for about half, recommended for let's say speed determination and so forth. Run the sprayer in a fixed position, and then start spraying and collect the spray water from each nozzle for 1 minute using a measuring pitcher like this. Okay. In this particular case, the assumption is, the assumption is that the sprayer is at the operating pressure, meaning that you have to make sure that your planned operating pressure is what you are using. So it's in place, and then you are using the operating pressure that you determined, which you used to do the selection, the nozzle selection. You use that operating pressure to run this and measure or collect the flow from each nozzle for 1 minute, meaning that you need some type of tubing to catch the nozzle flow so that you can collect that. And so once you have that, you calculate the flow rate of each nozzle as collected volume divided by 1 minute, and that will give you volume like gallons per minute. Okay. We can also simply collect the value, you measure it in ounces and divide that value in ounce by 128, and that would be a quick way to get the value in gallons per minute. Then we calculate the spray output as a sum of the nozzle flow rates, or each individual nozzle flow. We put all that together, and that becomes the total flow rate, which is what we consider the sprayer output. A similar measurement from the second one is what we present in the third method. In this third method, you fill the sprayer to a tank to about half, run the sprayer in a fixed position using the same operating pressure and so forth, and you have a tubing to catch the spray, and then run the sprayer, start spraying and collect the spray water from each nozzle using a nozzle calibrator. Okay, there's an automatic calibrator. It doesn't need any calculation. It rather has two probes and once you start filling the container, it starts timing from the first probe and it stops timing from the second probe. All the calculations are have been embedded into it. It just gives you the flow rate in gallons per minute or liters per minute or whatever you choose. There are different options on that. So that is a quick way to do it. And then the fourth method is just an elaborate method, which involves, measuring all at once and using this device. And of course, that this is a bit bulky and not regular use for everyday folks, but maybe for research or something like that, or demonstrations. So again, ensure that your pressure reading is right, your pressure gauge is working, is in good working good working condition, and then use that. That gives you the basis that you will be doing your calculations right, and selecting your nozzle appropriately and so forth. Okay, now this is a demonstration of measuring the spray output based on two of the methods. I think this is a method 3. This is an example of the automatic nozzle calibrator. And ideally, when you hold this, you have to hold it in a complete vertical position, but otherwise, if it's slightly tilted and you also maintain that throughout the flow, that should give you accurate measurement. And we have used this in different scenarios. We've compared this to the other one using the pitcher, and this has been spot on, just as the name said. This particular case is showing you 0.48 gallons per minute. So there is no calculation involved in this if you're using one of these. The next case is showing a demonstration of the just using this is just a demonstration of using the pitcher, and this will involve using the pitcher and then a stopwatch. So you time when you start catching the spray, and then you stop it and pull the pitcher from the flow, and so you do that together, and then you have the time and you have the volume. And ideally, this has to be placed on a level surface, maybe a table, or maybe sometimes you can find the part of the sprayer that is level as much as possible, and read. The problem with reading the value like this with the eye is that you can be off by a significant amount. So using volume is a bit tricky. I prefer to use weight, but it's measuring the weight of the water. That will give you a more accurate measurement. But in the field, maybe that is not the option. So the best option, or the closest option, is you putting this on a level surface and reading directly the volume and using that in the calculation. If nothing at all, this is as close as possible that you can get to it. And then again, I mentioned that when you use that, then you do it, or you can read it in ounces, the volume in ounces, and just divide by 128. It's just a relationship between the ounce and gallons. So this will give you, because if you do this for 1 minute, then you don't need to do any other calculation because it's per minute. So you just take out the volume, and this is it converts it to gallons, and it's gallons per minute. Okay. So now when we are done with that, we have to put these readings, we already have the flow. We have just determined the flow rate from all sides, from all nozzles. This is it. And we have determined the travel speed, miles per hour. And we know the row spacing. Okay. Here, when we put all of these back into the formula, this will give us the actual the actual application rate, which is gallons per acre. This is what we've been chasing all along. So we find it, gallons per acre. Now the question is, does the value come close to what I'm looking at, what I want to apply? If it's as close as possible, less or equal to, you probably will leave it there. Maybe if it's 95 against 100 gallons per acre, you probably will leave it. You can leave it there, or you can adjust it directly to get to 100 gallons per acre. And because it doesn't, the calibration, what we are covering in this, does not get to the mixing itself. I mean, it gives you the opportunity, it brings you to that point, and then when you are doing the mixing, the application rate itself will be used in determining how much volume, how much product should be added to the tank. So beyond getting the application rate, we'll be looking at you'll be looking at the product amount itself too. So the adjustments may not be that much necessary, but at least you know the actual reading. This is also why sometimes if you are using the same nozzle and it's appropriate for your particular case, maybe you may not go back to the catalog to select a nozzle. You're using whatever you have in place, but then you work through that, you use that, work through the processes. I mean that you skip the nozzle selection part, but the nozzle selection part from the catalog, but you have to still go through the air profile assessment to know which nozzles, number of nozzles need to be open, and then also getting the flow rate, and I'll bring that here to determine what the application rate is. And once you have that, for the two-sided situation, we just put these here. One-sided situation will be similar, but just taking note of the conversion factor. And so here, once we have determined that and we know whether we want to adjust or not, and the option is to adjust, this is where we come to this point. So let's see. Okay. So there are two ways we can adjust the application rate. We can adjust the travel speed, or we can adjust the operating pressure. In this particular method, we are looking at the travel speed, and this is a different formula from what we have been looking at. So pay attention to this particular case. So this is what we are looking. We need to be using. We have already measured the travel speed, which is this one, MPH measured. We have calculated the gallons per acre based on all those measurements. Here is that one. Now, the GPA desired is what we wanted to achieve. So let's say we have, this is, in this case, this is 100 gallons per acre. This is what we want to achieve. But when we did all the measurements, did all the calculation, we came to 110 gallons per acre. This is not what we want to achieve, this is what was measured from our calibration. We don't want this because this is over what the product label is asking for. target was 100 gallons per acre. So we want to beat this down to 100 gallons per acre. So what do we need? Maybe we measure this to be 2 miles per hour, the travel speed. If you put these values in, this comes to 2.2 miles per hour, meaning that you really need, instead of 2 miles per hour, you really need to be going at 2.2 miles per hour to achieve 100 gallons per acre. Otherwise, if you maintain it at 2 miles per hour, you're going to apply more than you need. Okay. So if you do that and you realize the measurement is, you have to really be using 2.2 miles per hour, then you will use that 2.2 miles per hour, maintain that adjusted settings for that application. Sometimes adjusting the speed is difficult because of the tractor settings and all those things. It's difficult to adjust to the 2.2 miles per hour. So in this case, the pressure will be, the best method to use. This is PSI is the pressure. This is what we want to achieve. This is what will give you this will be the adjusted pressure. Together is adjusted pressure. We take the gallons per minute desired. What do we need? And remember, we can get this one from the original formula when we do that change of subject, and this is what we use to determine the number of the nozzle flow rate. This is what we use to determine the nozzle flow rate that we were looking for. Okay, so that value here, and then the pressure measured, the pressure on your pressure gauge, and then this one is the gallons per minute that we have measured after we put the nozzles in place. So the first one is what the gallons per minute that we use to determine the nozzle flow rate we wanted. This one is after we have put the nozzles on the sprayer, the flow rate, the total flow rate we got from the nozzles after we have actually put the nozzles on the sprayer. And then this is the PSI that we measured. If we put all the values in, so in this case, let's say we were based on the desired application rate, the gallons per minute that we needed from all nozzles was 2.424, and then the pressure was 160. Okay, but when we put the nozzles on and we check the flow rate, it came to 2.376. So this value will not give us the desired application rate. So since 160, since this is our desired, if you put this in, and mind you, this is a squared and this is also squared. If we put this in, then we come to this value 166.53, which is the pressure we should be using, meaning that we need more pressure. Okay, because in this case, if we look at, we needed 2.42, but we are getting 2.37. That means that we are applying the spray, the gallons per acre will be less than what we need. So if you do this adjustment, it comes to 166.53. What can we do? Maybe 166 PSI. So use a 166 PSI, maintain that adjusted setting of 166 PSI for that application. Then you will get close to what close to what you want to apply. So these are the adjustments that, as necessary, if you need to do this, and especially in a case where you're maintaining the nozzles, this becomes necessary to do from time to time, moving from one scenario to another. So that takes us through the main what do you call it, steps of the for calibration. But I want to add some other aspects, which is the last step, which is basically a verification step. And before that, we want to look at quickly look at some definitions. So application rate, as we define, is the amount of spray applied per application area. So it is a broad application rate, what was applied over that area. And we know that the tree or the vine is not just like the field crop that is on the ground. So it has a structure. It's a three-dimensional thing. So that is why we need to also adjust, you know, the nozzles and air veins and so forth, so that they are applying to the spray, the target canopy. The application rate alone does not assure you of your effectiveness, because it's just about how much am I applying per that ground area. But beyond that, you know, we also need to look at coverage. And this is not really about, it's about where the spray is able to reach and cover within the target canopy. Is it able to reach some critical points within the target canopy? And I would say again, coverage does not mean that that spray is depositing on the target. Coverage just gives you an idea that, oh, my spray was able to reach here. And when you measure it visually, it will tell you, I give you a visual idea of how much of the spray, what is the density of the spray that reached those points. So coverage is a distribution of the spray over the target area. Okay, if there is no foliage, you can still capture that, but it tells you how much, this is how much is coming to this point and so forth. And we use water sensitive cards. These are yellow cards that turn to blue upon contact with water. You put these at different positions, different locations within the target canopy, so that, you know, you want to see whether the spray is able to reach all of these different locations. So you put that into the target canopy. You put that into different places in your target canopy, and then you capture it. You know, there's just a depiction of it. Small droplets will appear like this. You know, different sizes of droplets will appear like this. But this is just a depiction that I'll show real ones in the next slide. So it's beyond the coverage that we look at the next definition, which is the on-target deposition. How much of the spray actually lands on the target? Okay, and this is something that we usually determine, you know, maybe experimentally. And so the best shot, our best shot is, you know, in a field situation, the regular operation is coverage. It gives you an idea of where things, where the spray is reaching. At the end of the day, we are looking at on-target deposition, which is actually the mass of the active ingredients, how much of that deposits per foliage area, per target area. Okay. And the next step, which I mentioned as the verification step, we're focusing on coverage. We're going beyond just the application rate, but focusing on coverage, so we can see, you know, if beyond what we are applying, we are actually getting close to what we are targeting, what the objective is. So this is just a depiction. You mean there are different ways you can use tags like this to hold water sensitive cards. You can place them at different locations that are critical for the particular situation, and then you run the sprayer using the water in the tank. Run it like a regular application and see, run it with the the travel speed, with the pressure, and all that you have calibrated for. Run it through that in one pass, and see whether the spray is able to reach where it's supposed to reach. This will give you an indication of maybe if you need to make some adjustments in the air direction, the nozzle direction, and all those things. It gives you an indication of that. And these represent different types of spray droplets, or spray quality, and depending on the location of the water sensitive card, you may have more spray or less spray, and so forth, and that will give you an idea of what type of adjustments you should do to improve the coverage at places where you need more but are getting less. And then we can use also you can quantify this. You can quantify this by looking at the actual value in terms of percentage coverage, and then using that to see the distribution of spray within the target canopy. So this is just some demonstration. You see we place some PVC tube in the front part, or maybe in the middle. This is the middle portion of this particular demonstration, and you see almost all the entire water sensitive card is tend to blow. This represents some examples of measurements that we did. This was from a vineyard demonstration. It was during one of our training sessions. I decided to use the demonstration, the water sensitive cards we use in the demonstration, to actually measure the coverage, and then use that to take a look at what is happening. Okay, so in this case we use two different types of nozzles. Okay, we had air induction nozzles on the left side. We had disc and core nozzles on the right side, and this was just a demonstration. Okay, we used the same amount of air. We had two settings for the spray, and mostly there are two settings of speed of the air, the fan air flow. We have a low setting and a high setting. So we tried using the low setting and the high setting, and then we also had, again, as I said, air induction nozzles on the left, disc and core nozzles on the right. And we placed a water sensitive card on the ground in between the rows. Here is the row we use for the application. We place this in the next row and place another one in the following row. So the next two rows to the left, next two rows to the right, and then we put some water sensitive cards in place inside the vine, where we would consider as a target, our target canopy area. So this particular plot shows the canopy coverage from this one, and so this is air induction nozzles on the left side, and this can go on the right side. You see the blue represents low fan. When we use low fan, in this particular case, we had more deposition or more coverage in the canopy. For if you look at the low fan versus high fan, you see that the high fan reduced the coverage, and this is seen in all the locations. This was the immediate targets, immediate target, and we placed this also in the next vine, okay, the next row. And so this is the target row, and these two are not the target row, but the next one beyond the target row. And so you can see the distribution of the spray. So in this case, we can say that low fan speed was better than high fan speed. And then here we we see the ground coverage from the ground, and this represents spray loss. What does not end up on the within the canopy, this is what is ended up on the ground. It's not what is flying or what is drifting, which we could use maybe these vine ones to give you some some sense of what is drifting away or potentially drifting away. But down here we are looking at what actually ended up on the ground, and I want to give an indication that while we're doing this was not a replicated experiment. This was just a demonstration. We just collected it. So in this case, when we're applying it, there was wind blowing towards the left. So I wanted to indicate that, and that explains why we have there was more ground coverage on the left, towards the left side than the right side. But even if we stay on just one side, we can see that we can see the difference between the low fan versus high fan. And here the ground deposit were more in the more nearer to the applied side. We see that the high fan gave less closer to the applied side. But what we observed, which this does not show, was that the high fan was carrying the spray further. So if you look at the closer proximity, it appears as though the low fan is giving more. But if you look at the measurements beyond this and going further, you see that the high fan was taking the spray a lot further than the low fan. So this is just to demonstrate that when we use a water sensitive card, we can come up with some other ideas. We can better understand the application and then have a better sense of what type of adjustments or what type of adjustments or changes we can make we can use to improve the application. So that is what it is. And this is also another situation where we did compare different different nozzle configurations. This is in walnuts. These are tall trees and large canopies. And this was, of course, at the beginning of the season. We're looking at this to see how far can the spray go. We placed these long poles with water sensitive cards attached to them on left side and right side of the sprayer. And we started off with the first demonstration. The first demo, we had 10 D525 nozzles in place. I think we did it. Yeah, we had the 10 D525 nozzles in place. And these were the other what our target gallons per acre and all of these were the measurements we have used. And then we changed from that and went to 5D725 and then 5D425. So 5D425 is on the lower end and 5D725 on the upper end. And then with the next one, we had 2D725s at the topmost end, the topmost part of the manifold, and then the next two were D1025s, and we had one D725, and the lower three nozzles were D425s. And these are 100 gallons acre, 100 psi, and then the speed was 1.9. So these are differences between the demos. And we wanted to see how high the spray can reach. If you look at this scenario, we can see that starting off, we have the blue representing first demo. Let's look at the bottom side and the top side. Okay, we had some missing data here, but if you are looking at just between demo 1 and demo 2, we see that we're able to the blue shows that first we had more spray coverage at the lower end than when you're going up. It reduced. Generally, you had more flow, you had more coverage at the lower end, and then this increased or decreased as you go up. So that wasn't what we're trying to achieve. If you look on the right side, it's a similar thing. You have more lower, and then it reduces as you go high. But we wanted this to see, can we push the spray upwards? Can we get more spray upwards? And so in the next demo, which is the orange or yellow, depending on how you're seeing it, this shows that there wasn't much of a change when we used that second configuration. It didn't change that much. We still could not get more spray up, and so we moved on to, it seemed like even there was a bit more reduction going up, and then we changed to the next configuration, a more complex configuration. And if you look at the green, which demonstrates that, you can see that now we're able to get more spray up. We're able to get more coverage upwards. Okay, if you look on the right side, it's the same thing. You see this reduced, but then this picked up. We're able to get push the spray upwards. And if you look at the topmost end, you can see that on the right side, we had very little coverage, and then the next demo was a bit more, but the third one even gave more spray upwards. So these are some things, some learning that you can gain from doing the putting the water sensitive cards in your canopy and assessing this. This may be a bit more than you are looking for, but if you're able to do this one time or the other, it can help one to determine, maybe what type of configuration gives me the best shot, and then this can be used, over and over and over in the coming years. So a little time investment, but it can yield a lot more when you put in, when you consider that this can be used over and over and over again. So thank you very much. I hope this presentation has been useful, and if you have any questions following this, feel free to send me an email. I'll do my very best to get back to you, or You can also leave a comment in this video. You can leave a comment below, and we'll do the very best to answer or reach out where necessary. Thank you very much, and I hope this has been useful. Thank you.